they will have very high specific heat. Say for example, if you are going to a park on a sunny day at 3 p.m. and temperature is 110 Fahrenheit outside, and you saw there is a metal bench and there is a concrete bench, which one you will pick to sit? We always prefer concrete over metal. Reason, metal will be very hot compared to concrete. So both of them are outside, same environment, same temperature, same sun, but both will absorb same amount of heat. They are both getting same amount of quantity of heat, but concrete will change temperature slowly, but metal will change temperature fast. Reason, metal will have low specific heat capacity. That means they need only little bit of heat to change the temperature compared to concrete. So that is called specific heat capacity. So quantity of heat needed to, quantity of heat means heat is Q. How much Q is needed to raise the temperature of that substance? And we are specifying if there is a 1 gram of substance raising 1 degree Celsius, how much Q is needed. That Q is called the specific heat capacity. You can write symbol is C. There are two specific heat capacity, one at constant pressure, one at constant volume. That's why you are seeing Cp there. You can simply write C. Specific heat substance is its capacity to absorb, how much energy they can absorb very fast to change their temperature. The very important factor you have to know, if they have very high specific heat, they need very high greater amount of Q. Okay, if C is high, Cp is high, they need higher Q to change their temperature. And since we are specifying grams and degrees Celsius and it is a Q required, so Q is in joule, mass is in gram, and temperature is always in degrees Celsius for specific heat calculation. Okay, so here there is a table given. You can see specific heat of different substances there. Okay, so there is something we already learned here. Water, which has, compared to all other, which has very high specific heat. The reason we already learned in solution topic, water has hydrogen bonding. So there is oxygen and hydrogen in water molecule are attracted using hydrogen bonding. So whatever Q you are providing is used for breaking this. That's why it needs more temperature to raise the temperature. So compare two other things. Say for example, if you have aluminum has 0.895 and another one is copper which has 0.387. So copper has very low specific heat compared to aluminum. Aluminum is a little bit higher. Okay, so if you want to boil something and you have a copper vessel at home and aluminum vessel at home, which one you will pick? You need to pick this one then, because that will change the temperature really faster. So there will be conceptual questions over specific heat capacity. So remember, specific heat capacity is low, means it will change temperature faster and needed low amount of Q. And the opposite is, if it is high, it will change temperature slower than less amount of Q. So according to the graph, what is the specific heat of water? It says 4.184 and the unit is joule over gram degree Celsius. And this is given on your formula sheet. On your test, you have to use your formula sheet to find that value. And another question, it says ethyl alcohol absorb 1000 joules. Ethyl alcohol and water both absorb same amount of joule. Joules means Q. Which would have the highest final temperature? Which one raise temperature faster? Oh, let's go find ethyl alcohol. Ethyl alcohol is 2.450 and water is 0.4184. So ethyl alcohol have low, that means ethyl alcohol will have highest final temperature. Because of lower specific heat capacity. So those are the things you need to know, you have to understand to answer some of the conceptual questions. Okay, then the calculation part. This is an equation, it is given in your formula sheet. You have to understand what each variable means. Q means heat. Remember, heat is needed to be in joules. If it is in kilojoules, you have to multiply with 1000 to convert that into joules. Okay, that means 1 kJ is equal to what? 1000 joules. Okay, if you write like this, you will get confused. Okay, then M is mass. Mass must be in gram, and remember, if it is in kilogram, you have to convert that into gram, or if it is in milligram, just use King Henry. And C or Cp, that is called specific heat, and the unit will be joule gram degree Celsius. And delta T, this one we will read as delta T, means change in temperature. The equation we are using, Tf minus Ti. Tf is the final temperature of the system and Ti is the initial temperature of the system. Okay, so let's go do a couple of practices. Read the question and label the variables. How much heat is what? Q will be absorbed by 34. It is absorbing, that means temperature will rise. Okay, 34.4 gram, that is the mass. And it says a substance name, ethyl alcohol. As it change temperature from initial is 25 and final is Tf, you are going to find Q. So write the equation Q equal to M times C times delta T. You can write Cp if you want. Okay, Q, we don't know Q, and mass is 34.4 gram, and we need Cp from, we can get that from the table. It is what? 2.450. So I'm going to write 2.450 joule gram degree Celsius, and delta T, the final temperature is 78.8 degrees Celsius minus 25.0 degrees Celsius. Okay, now the units, we need to get rid of the units. Like gram and gram will cancel. Celsius and Celsius will cancel from here. And do the calculation. You are basically multiplying 34.4 times 2.450 times what is 78.8 minus 25, that is 53.8, and only unit left over is joules. So your answer is, and look at the sig everything. This one has 3, 4, 3. So we will write the answer in three digit. So you will get 4,510. 4,510 joules. And since it is absorbing, it will be positive. You don't need to write the symbol, just write that. But you have to understand it is absorbing that much heat. So the answer is 4,510 joules. Okay, let's do the second question. It is the same type. This time it is asking for something else. Okay, I'm going to erase the previous one so that I have space for writing it. Wait. Calculate the temperature change. It is asking for temperature change. That means it is delta T of mercury, and it has a mass of 160 gram, absorbs this much heat, and the specific heat, which is Cp, is also given. Okay, so write the equation. Q equal to M times C times delta T. You can write Cp. Q is equal to 1,500 of joules, and M is 160 gram, and Cp is 0.14 joule per gram degree Celsius times delta T. That's the one you are finding. Then basic algebra. If you don't know algebra, what you are going to do, you will divide this number with these two. And the units, you see, joule and joule gone, gram and gram gone. So only thing is remaining is degree Celsius. So your answer is 67 degrees Celsius with the correct sig fig of 2. That is your final answer. That is a change in temperature. Okay, now there is a conversion question. We already said how to convert joules to kilojoule, joule to kilojoule. Okay, so we know that 1 kJ is equal to 1000 joules. Okay, so it is 3,548 joule will be what? You don't need a calculator, or you don't need to write a step for this. I'm just writing since you need to understand, some of you. So just divide with 1,000. So the answer is 3.548, and unit will change into kilojoule. So kilojoule will be a small value because we know that the bigger unit you will get a small value. Smaller unit you will get bigger value. Okay, so that's next one. Let's go do this third question. It is asking how much heat Q. Remember, there is a question. It's asking in kilojoules, and there is mass given, and it cools from means this is a starting temperature, and this is the final temperature, and Cp is also given. Okay, so go down, write Q equal to M times C times delta T. M is 85 gram, C is 0.11 joule gram degree Celsius, and delta T, what is 210? The difference is, yeah, it is minus 190. Remember, then your answer will be negative because it is releasing. So this is minus, but you don't put that on your calculator and make a mistake, and just need to understand that negative symbol will be there. So then multiply, and you will get the answer 1000, round your answer to 2 sig fix, so you will get 1800 joules, and convert that into kilojoule by dividing with what? 1000. Okay, 1000 joule is equal to 1 kilojoule, so your answer is 1.8 kJ. Don't put 0, then the sig fig will change. Okay, and this answer will be negative. And remember, if something is releasing heat, given out means it will be negative. You got a negative from here, that when you multiply, your final answer will become negative. Okay, next question is little different type. Maybe you may need to use little of algebra to do it. Okay, let's go do that. I'm going to erase the previous one. Okay, it is asking for the final temperature. So this time we are going to find TF. Its joule is given, which is Q, and it says added. So 38 gram is the mass at this temperature. So that is the beginning temperature, which is initial temperature, and Cp is also given. Okay, same equation, right? Q is equal to M times Cp times delta T. M cat, you can remember like that. Q is equal to M. We know Q, so let's substitute that also. So Q is 1404 joules, and mass is 38 gram times 0.024 joule gram degree Celsius, and delta T, and we know the equation, delta T is equal to T final minus T initial. Okay, so T final we don't know, just write TF minus Ti is 26 degrees Celsius. You can do this in multiple steps if you want. If you are struggling with algebra, do that way. Find the delta T, then do it. Okay, so easy way to do it. I will divide this with these two number. Whatever number you are getting, you will add a 26. So your answer will be, let me get the calculator and do it. Don't have the final answer. Okay, give me 1 second. So it is 1404 divided by, start up parenthesis, 38 times 0.024. Okay, so you will get this answer is 1539 is equal to TF minus 26. Okay, then TF is equal to, you add 26 on both sides, so it is 1539 plus 26. So add 26 into that, so you will get 1565. Okay, now we need round that to 2 sig fig, so your answer will be 1600. On level you can keep the same value, but advanced needs to round that to 2 sig fig, so that will be 1600 degrees Celsius. Okay, so same way, do one more question. After that, this page is the practice, and come check the answer key in class. Okay, so I'm going to erase this. Let's do this one. It says 500 gram of a metal absorbs this much Q, and the temperature changes from initial to final. you are going to find the Cp of the metal. Okay, so equation Q is equal to m times Cp times delta T. Q is 5016 joules. M is equal to 500 gram. Cp is equal to, we don't know. Delta T is 30. So remember Tf minus Ti. So it is 30 minus 20 will be what? It will be 10 degrees Celsius. Okay. So now get your calculator. You are dividing this with these two numbers. Okay. So you are dividing Cp will be equal to 5016 divided by 500 times 10. You can do that easily. 500 times 10 is 5000. Okay, and the only unit remaining here, so now everything will be remaining joule per gram degree Celsius. So that's how you are getting the answers. So you need to round that. Okay, that will be a very let me calculate that for you. 1 minute. 5016 divided by 5000 will be 1.0032. Okay, but we need only one sig fig, so you are writing your answer is 1 joule per gram degree Celsius. Okay, that's how we do the calorimetry, specific heat calculation. Then this page is the practice. If you are absent in class, do that at home and check your answers with me later.